Hi, Stats 310 students. It's Eric. I'm back with you with another Excel demo. I wanted to go through a couple examples of the normal curve calculations that Excel can help you do. So I picked a couple problems out of the book that are similar to some of the homework problems, and let's take a look at them. I wanted to start with an example with just the standard normal curve, and so I picked question 6 from chapter 6 on page 209. I had you guys do number 7 from the same chapter, so hopefully this will show you the kind of thing I'm looking for you guys to do for this. And so this is just about the standard normal curve. In other words, the normal curve that's centered at 0 and has standard deviations going out 1, -1, 2, -2. And the idea for this is that you get to use z-scores. Z-scores that just tell you how many standard deviations you are away from your center, which in this case is 0. So before I get started on the actual questions in this, I wanted to show you how Excel wants to do these computations. So I've started with not part A, a question before part A. I want to know the probability that you're going to get in the standard normal curve a z-score below 1.96. So to do this, we're going to do that this is equal to, start typing norm and see what comes up. And notice I've got something called NORM.DIST, but because I'm on the standard normal curve, I actually want NORM.S.DIST. That S indicates standard. And notice it just wants to know two things. It wants to know a z-score, I've got it over there, and it wants to know whether I want cumulative. And the answer is yes, I want cumulative, so I'm going to hit true or 1 in that part of the for that part of the function. And the z-score is 1.96, comma, I'm going to do 1 for true because I want the cumulative. I want to know what proportion of the curve has accumulated as I've gone from -infinity to 1.96. So I just hit enter, and I get that it's 0.975 of the data. Now the way the Excel function works is it will always tell you the proportion of the curve to the left, or in other words, the probability of picking a score less than or equal to, or just less than, the given number you give it, in this case 1.96. But notice the question for part A asks, what's the proportion of the data above 1.96? And that's really not hard to do if you just remember that the proportion of the data, the total data, is 1. It's a probability curve, so the entire data has to be, the entire area under the curve has to be 1. So in order to figure out the answer to part A, I've already figured out the area of the curve to the left of 1.96, so to figure out to the right, all I have to do is say that this is equal to 1 minus the number I just computed. And there you go. So now something a little trickier, figuring out what is the area between 2 points. So because the function that Excel does only gives you the area to the left of the curve, what I need to do is figure out the area to the left of my right bound here, which is 1.6, and then subtract off the area to the left of that, the area to the left of 0.6. So I'm going to ask Excel, what's the normal cumulative distribution to 1.6, and that'll be a number, and then I'll subtract the number that represents the cumulative distribution to 0.6. So I'm going to have to do 2 normal function calls here. So this is equal to, again, we'll do NORM.SDIST, and I'll do 1.6, comma 1, and now minus, same thing, there's NORM.SDIST, 0.6, comma 1. And there we go, 0.219. So that's saying 0.219, there's a 0.219 probability of picking a z-score between 0.6 and 1.6. And I'm going to leave part C here, which is pretty much the same, except it's with negative numbers, for you to try on your own. Now moving down to question number 6.38. This is on page 227. This is some data about cell phone calls. And this is giving us a non-standard normal curve. In other words, it's a normal curve where mu doesn't equal 0 and sigma doesn't equal just 1. So we have to actually translate these scores into z-scores, but fortunately Excel's norm distribution will actually do that for us. So again, I'm going to do equals, and now notice I've got a probability that the length of a call is greater than 6. This means, again, just like with the standard normal distribution, Excel only returns things to the left. It only returns the probability that something is less than that. So I'm going to start by doing 1 minus, because I know Excel is going to want to compute the probability that it's less than 6. So I'm going to do 1 minus to get the probability that it's greater than 6. So I'm going to do 1 minus, let's see, norm. And now I'm just going to use NORM.DIST. I can't use S.DIST because I don't have a standard normal distribution. I have just some arbitrary normal distribution. And so notice now Excel wants more information. First it wants the x. Okay, so that's 6. But then it wants the mean because it doesn't know which normal curve you're looking at. You told it it's not the standard one, so it needs to know where that curve is centered. And that's this right here, 5.36. And then it wants to know the standard deviation. How wide is the curve we're dealing with? Well, that's 1.2. And again, it asks for cumulative or not, and as always with normal curve computations in this class, we're going to do cumulative. And there you go, 0.29. So almost 0.3 of the calls are greater than 6. And now for part B, what's the probability that a call will be between 3 and 5 minutes long? Well, just like we did in part B in the problem above, we need to figure out the probability that's going to be less than 5 first, and then subtract off the probability it's going to be less than 3. That's going to be the probability that will be between these two numbers. So same drill, equals NORM.DIST. And we're going to start with 5 because we want our right bound. And our mean is still 5.36. Our standard deviation is still 1.2. And still, as always, we want true for cumulative. And then if I just hit return, we'd find the probability that we had a call less than 5 minutes. But we want to actually figure out the probability that's between these two. So we're going to do minus NORM.DIST. Let's see, 3 this time because we want the lower end of it, comma, B9. Oh. Let's see, B9, B10 for our standard deviation, and finally 1 for true. And there it is, 0.35. So just over 35% of your calls come in between 3 and 5 minutes. Now we have a slightly trickier question. And the question for part C says 80% of the calls are between what two values? In other words, what are the middle 80% of calls here? And so to figure that out, we need to figure out, okay, if you're in the middle 80%, then you've got the top 10% excluded, and you've got the bottom 10% excluded. Unfortunately, Excel has a way to find both of those numbers. So first we're going to do equals norm, and I'm going to use NORM.INV. This is norm inverse because what it's going to do is say, okay, instead of you giving me an x and I'll turn it into a probability, you give me a probability and I'm going to turn it into an x. So it's doing the computation backwards. So if we want the middle 80%, we need to cut out the bottom 10%. So I'm going to start the first number, the lower number. It's going to start at 0.1. because that's the bottom 0.1 or bottom 10%. Then it asks for a mean when we're doing the same distribution. And then it asks for a standard deviation. So there we go, 3.822. So that's telling us 10% of the calls are shorter than 3.822. And now we want to know, remember the question asked that 80% of the calls are between what and what? Well, we've got 3.822 as our lower bound of that, and we want to now compute the higher bound. And we need to think for a second because the higher bound, that's the bound where 10% of the calls are longer than that. But because INV.NORM, just like the regular norm function, only wants the lower, the accumulating from the bottom, we need to realize, oh yeah, 10% above means 90% below. So I'm going to do basically the same thing here. NORM.INV with 0.9 and get 6.89. So that tells me, okay, 10% of the calls are below 3.822. That was the first value I calculated. 90% of the calls are shorter than 6.89 minutes. So that means 80% of the calls fall between 3.8 minutes and 6.89 minutes. Anyway, I'll upload this Excel spreadsheet to the class resources so you can take a look at it and look at how the formulas came together. And also there's a part D to this question that I'll leave for you guys if you're interested. Thanks, and I'll talk to you soon.